Okay, so with this one, we are going to explore changing quadratic relations and then using the values of h and k. We're gonna, at the end, we're gonna put it all together. Okay, A, H, and K to create the vertex. Okay? But for now, we're gonna do one by one. So K is added to the parent function. So you have x squared, K is outside your parent function, it's added to it. So remember that x squared at a vertex of 0, 0, opened up, axis of symmetry of 0, x equals 0, and the optimal value is 0, right? Remember, we're always comparing to it. Now we're going to graph x squared plus 2, x squared plus 4, x squared minus 1, x squared minus 3 on decimals, and then we're going to see what is happening to the graph. Okay? So let's go to decimals. You guys can go on your decimals as well. I'm gonna, as usual, I'm gonna start with x squared because we always have to compare to that. And then what was the next one I have to write? Y equals squared plus 2. What do you see? The vertex changed. What's the vertex now? 0, 2. Okay, the vertex is 0, 2, right? This is your vertex. You see it?
Yeah, 1 is 2. Okay. 1 is 0. There's 2.
The original, which is x squared. The red one is 0, 0.
But now it's 0, 2 now first.
Now it's 0, 2. So what did that 2 do to your graph? Huh? It moved it up 2. We call this a vertical translation. Move up means vertically, right? Vertical translation. So it moved it up. Okay? Let's, what's the next one? Y equals what? X squared plus 4. Where is the vertex now? Up. 0, 4, right? So what part of the vertex is that k value changing? The x or the y?
Y.
The y. It's changing your optimal value. You guys remember that? Your optimal value is 4. Your optimal value here is 2. So we see that it's a vertical translation. In this case, it's up 4. In the first case, in the blue case, it's up 2. What do you think is going to happen if I have a negative k value?
It'll create a reflection.
It won't be a reflection. It will be vertical translation down. Okay? What was the next one? Y equals x squared minus 1. You see where your vertex is? It's still opening up because my a value is 1. The only difference is the vertex is 0, negative 1. Okay? And the next one would be y equals what? X squared minus 3. So you see that your vertex is at 0, negative 3. Okay? So that, we call this the k value. The k value affects your optimal value, and it affects the y value of the vertex. Okay?
The axis of symmetry could change?
Sorry?
The axis of symmetry could change?
It does not change.
It does not change, okay.
So the only thing that's changing is your vertex, the y value of the vertex. What? Okay, so let's write this down. So the value of k is
Two.
2. Direction of opening,
Up.
up. Vertex,
0, 2.
0, 2. Axis of symmetry,
0.
0. If you want to compare it to the shape of y equals x squared, what do you say? Vertical translation up. How many units? 2. 2 units. Okay? From now on, I'm going to write vertical translation as VT. Because I don't want to keep writing vertical translation. You can do that on the test, yes. Okay? So, what's the value of K here?
4.
Direction of opening.
Up.
Vertex.
0, 4. 0.
Axis of symmetry.
X equals 0.
And vertical translation up 4 units. Excellent. When we're talking about vertical translation, we're actually taking the graph and we're moving the whole graph up. Okay? So all what's happening is that your y values are being added. So you're adding 2 to every single y value. Okay? You're not stretching, you're not compressing, you're just moving the whole graph as is, the x squared, you're moving it up. Okay? Graph? Yeah. The whole, no, the parabola. The parabola is a graph. Yeah. Not the grid. The graph, the parabola. What's your value of K here?
-1?
Down. 0,
It's up, the opening is up.
What?
Yeah, look.
Oh, yeah, you're right.
Look, they're all opening up. U shape. 0, -1. X equals 0 for the axis of symmetry. Vertical translation. Down 1. Okay? This is where you say down. You're moving it down. Okay? You're taking
Because of negative.
Do you always have to state the number of units?
Yes. When you're doing vertical translation, you have to state the number of units. So when you're saying vertical translation, you have to say how many units up or down. Value of K is -3. Opening up. Vertex is 0, -3. Axis of symmetry is at 0. Vertical translation down 3 units. Okay. So how does the value of K affect the basic parabola? When K is greater than 0, so it's positive basically, the parabola shifts upward. Yeah. When K is less than 0, so it's negative values. I'm just going to put negative values. The parabola shifts downward. The K value describes the optimal value, yeah, of the parabola. Actually, no, it describes the, I want to say vertical translation. The value of K describes vertical translation, yeah. Describes the translation of the parabola. It's also known as vertical also known as shift. So we're gonna stick with vertical translation, okay? So we don't mix the shift and the stretch, vertical shift, or the optimal value of the problem.
So the vertical shift is the vertical translation?
That's the same thing, but we stick with vertical translation because then we can write it as VT, right? Because VS can mean vertical stretch.
Oh.
Okay, so we're gonna stick with vertical translation. Okay, so let's look at the two equations that we see there. So we have state transformation and then we have to graph. So what kind of transformation do you see here?
Press up.
Vertical translation, 3 units up. You see how I'm saying it? You have to write it. Okay, I'm looking for that vocabulary. So it's called vertical translation, so VT, 3 units up, or up 3 units, doesn't matter which way you want to write it. Any other transformation that I have here? No. Right? What's the vertex? 0, 3. 0, 3. So the vertex is 0, 3. Remember that if it's in this form, I can use the transformation. So what are my, the step pattern? What's my step pattern?
1,
1, 3, 5. Nothing's happening to it, right? Because my A value is 1, right? So the step pattern is 1, 3, 5. So if I want to graph this, so I'm gonna start, where's my vertex again? Can you guys remind me? 0, 3. So 1, 2, 3. So this is where my vertex is. From the vertex, you're gonna go 1 up over 1 because it's 1. So I'm gonna go up 1 over 1. Then after that, how much do I need to go up?
3.
Up 3. So 1, 2, 3 over 1. After that, I have to go up 5. Can I fit that on my graph? No, so I can forget about it. Okay? This is enough data that I can actually sketch my graph. So you start from the vertex. That's your most important point. And then from there, you're gonna have to follow your step path. Let's look at the next one. The next one is y equals x squared minus 2. What kind of transformation do I have? Vertical translation 2 units down. What's my vertex? 0, negative 2. Step back.
1, 3, 5.
Locate the vertex. So the vertex is at 0, negative 2. So it's right here. Then I have to to go up 1 over 1. Then from that point, I have to go up 3 over 1. And I can go up 5. Let's see, 1, 2, 3, 4, 5. Yeah, over. And that's it. Including values on your graph, on your grid, is very important. Okay, so it's important that you have the value, like the 1, 2, 3, and the values on the x as well. Just one moment, I'll come back to this.